Hello and welcome to this C programming video. My name is David Thorne. In this video I'm going to show you all about how to write to standard out. There's three different ways I'm going to show you in this video. There's possibly more, but I'm just going to show you the different ways to do it. So the first way I'm going to show you is the Unix way, using the Unix standard library. Okay, this is a bit more of a lower level way of doing it. So we're going to say Unix standard library header in here. This is our message that we want to write to the standard out. And to do this, we're going to use then the write. And here we have then a file descriptor, which is an integer. I want to point out here that it's an integer, not a pointer. All right. And then we have a pointer to a buffer. And then we have the number of bytes that we want to write to. So in order to do this, we need to say, first of all, the file descriptor and the file number. So we're just going to say file number for the time being. And the buffer that we're going to read from is then the message. That is then the pointer that we're going to read from. And then the number of bytes that we're going to write. Okay, well, the file number, first of all, we can do by saying file number. And we can use a function of file number here, or we could just say standard out underscore file number. We'll use that initially, and we'll talk about the rest later. So otherwise, we're going to say a size t is equal to 0. And obviously now we need to work out the length of this one string. Okay, and we could use the string.h, but that wouldn't be any fun. So we're going to say here, whilst message and then the index of size is not equal to the null terminator or /0, whichever way you want to say it. We're then going to increment the size, and this will now give us the length of this one buffer, let's call it instead, and it's going to write now to that one file number. So let's run this, and you'll see this is my message to standard out. Now, we could also say file number, but as you notice, the file number function is not there right now. This is more something that comes in with the standard IO, include standard IO, and now you can see that we get this file number here. And let's just go and have a look inside, and you'll see that it's inside the standard IO. So you could, if you wanted to have standard IO in here, which would kind of not make sense because you could just use Printf instead. So you now know that if you don't want to use standard IO and you just want to use the Unix standard library, then you're going to need to use this constant here that's been defined for you to say that it is the standard out file number is number 1. You could obviously also just write number 1, but then you wouldn't be making code compatible for different platforms. All right. So we've now got the length of the string, which is good. So I've now shown you how to do it using the Unix standard library. We're next going to go down to the fwrite instead, and this is then going to be a part of the standard IO again. So if we look, we can see it's inside the standard IO, and when we look at this, you'll see that we need a void pointer of restrict pointer. So we need a pointer to a place in memory, and then we're going to say the size of that one area, or the size of the chunk, we're going to say, and then this is then the number of items, so the number of chunks that they need to write, and this is where it's writing it to. All right, so we've got what we want to write to memory is the message, the size of the chunk that we want to send. Well, size of char is what we want to send. How many chars do we want to send is size, and then where do we want to write this to? We want to write it to standard out. Okay, and when we run this, you'll see this is my message written, message to write to standard out. So this is basically fwrite is literally sat on top of write. Okay, so you don't need to use write because fwrite is just basically doing this for you. All right. So once we've done this, we then know that we can use Printf. Okay, and Printf is just basically using a formatted string instead, which sits once again on top of fwrite and or write, and here we can just then call it outright, and we say this is my message to write to standard out. So this is this is something, obviously you don't need write because you've got fwrite, and if you want to use fwrite, if you don't want to mess around with fwrite, you can just use printf, and it does it all in the background for you. All right. So with that said, this was a short, sharp video, but it also identifies to you how the system writes data to files. All right. Now we know that when we say standard out here, this is a pointer, right? Because we looked at the fwrite here, and you've seen you need a pointer to a file, okay? And now we've seen that the file descriptor, every file has a descriptor, right? And it's just generally a number on a Unix system. So that's why a very, very low level, we only work with file numbers. But when you go up a level, you start working with pointers to files themselves. And then obviously here we are writing chunks of data rather than... So fwrite is more made for writing the likes of structs. So if you have one struct, you say what the size of that one struct is, and then you could write 10 of them to a file in like binary mode or whatever. And then it would write these directly to the file, okay? But if you want to write it byte by byte, then obviously you can do it this way too. All right. So a char is synonymous to a byte. So, but I just wanted to show you the different levels of how to write to standard out. Obviously, standard out, error, and standard in are basically or your standard out and standard in. If you want to write to standard in of another process, that's something else. Otherwise, if you want to write to standard error, they all basically do the same thing, but they're all point to different file descriptors. All right. With that said, I hope that you've got something out of this one video. If you did, don't forget to like, subscribe, share. And if you notice the date that I create these videos, I'm making it on the 24th. And this video is going to be released on the 27th of September right now, because I have other videos already planned for tomorrow and 26th and so on. Now, if you want to be able to access these videos and you don't want to wait for them, which is super cool if you feel that way, then you are more than welcome to become a member. And one of the perks of, actually the only perk right now of that, is that you can access all videos as soon as they're released and made public by YouTube, or however long it takes for YouTube to say or send you out a notification that they are made public. All right. So, but that's something that you don't have to do, but just to show your support to me, it's a way that you could show me your support, which you're supporting my channel already, which is super, super awesome. With that said, if you do have any questions, feedback, or concerns, then please start a conversation in the comment section down below. You are all very important to me, and all of your comments or questions and stuff are important to me as well. And this is why I'm going to start doing the memberships now, because I want to start directing the content based upon what you want rather than what I think you want and so on, because I know what level of programming I can do, and with the memberships I can then work out what level of programming you want to get to, and the type of instructional techniques you like. And if you like my instructional techniques, then I should try and find some more content that would make you happier. With that said, thank you very much for watching, and I will see you in the next video. Ciao, ciao, and goodbye.